So in chapter 1, we learned about solving different types of equations. Chapter 2 is what I call a hodgepodge. It's kind of like the author didn't know where to put this information, so I put it all into chapter 2. So the one thing you're going to notice about chapter 2 is the first section does not really lead into the second section, which doesn't really lead into the third section, but it is all important pieces of information we're going to need in order to be successful in chapter 3. So in section 2.1, we're going to start off with the distance and midpoint formulas. These are formulas you need to memorize. You will need to know them in order to take the exam and the final exam. So let's start off with the distance formula. I think it's important that you recognize where it comes from, which will help you memorize it or learn it so that you can derive it each time. So to get to the distance formula, we're going to draw quadrant 1, and we're going to label 2 generic points. So this would be point 1, so P1 meaning point 1. And I'm going to label its coordinates as x1, comma, y1. I'm going to have a second point up here, which I'm going to call P2 for point 2. And its coordinates are going to be x2, comma, y2. What we're trying to find is this distance between them, which we'll use a lowercase d for that distance. So literally, if we took a ruler and we had a nice grid system measured out in inches, we'd take the ruler and measure that distance. So we need to find that distance. To find that distance, what we're going to do is consider this to be a right triangle. So we're deriving the formula now. We're going to look at this as a right triangle. So we have 2 sides to our right triangle. We have this side sitting over here, which would be the distance between y2 and y1. And we have this side, which is from here to here, and it would be the distance or difference between x1 and x2. So what we're really saying is that this side, which is corresponding to this side up here, of that right triangle is really the distance x2 minus x1. So in other words, if this were over here at 8 and this were over here at 3, to find the distance between those two for that length of that side, you just subtract them. You can say the same thing over here to find the distance between these two. It would be y2 minus y1. And that sets us up for the Pythagorean theorem. So a squared plus b squared is equal to c squared. And for the Pythagorean theorem, the c is always the hypotenuse. We talked about this in section 1.7 on the application problem. So we're going to come in and take the quantity x2 minus x1 squared. That's this side of that right triangle. Plus y2 minus y1 quantity squared. That's this side of that right triangle. And that's going to be equal to d squared. Now, because we're looking for a specific formula that solves for distance, we're going to square root both sides. So here's our formula. It says that d is equal to the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. And there's your distance formula. And we derived it. So again, you don't necessarily have to memorize it as long as you know where it comes from. You can kind of see the formula in play. Let's use it. An example. So in example 1, it asks us to find the distance between the pair of points. So it says really the distance P1 to P2. So we're talking about the distance from P1 to P2. They then go on to tell me that P1 is at the point 2, comma, -3, and P2 is at the point 4, comma, 2. Yeah, well, I'm going to come in and label them to help me get them into the formula correctly. So I'm going to call this one x1, this one y1. This is x2, and this is y2. So now when I pick them up to put in the formula, I know what numbers I'm putting in. Then we'll write the formula. It's just going to help us memorize it. So the distance is equal to x2 minus x1 quantity squared plus y2 minus y1 squared. Now we'll plug in our numbers. So x2 is labeled as 4 minus x1, which is a 2, and I'm going to square it. So all I'm doing is replacing x2 with the 4 and x1 with the 2. Plus, now we're going to replace y2 with that 2 minus y1, which is a -3. Now all we need to do is clean this up. So we'll do it a little bit slow for the first one. So 4 minus 2 gives me 2, which we're going to split. The negative line, sorry, subtracting a negative 3 is going to make that a plus 3. So 2 plus 3 is going to give us 5, which we're going to square. So 2 squared is 4, 5 squared is 25. We're going to end up with the square root of 21. Now that's the exact answer. Only take it to a decimal if it's an application problem where they ask for a decimal. Otherwise, this is the answer. You do need to simplify radicals, and we'll work on that in the next example. But there it is. And that's the first example of the distance form.